It can be hard to get your big idea started, to write the first lines of code for software that will change the world, to hire the team that will make your dream a reality. That's why we built a different cloud, one that's comprehensive without complexity, that gets you up and running in minutes and stays with you every step of the way. Because simpler tools lead to happier developers, and happier developers get better results. Build with us. Grow with us at DigitalOcean.
All right, welcome everyone. Thank you for being here. This is a DigitalOcean Tech Talk, and it is May 11th, 2022. And this talk is called Managing Kubernetes Secrets, Comparing External Secrets Operator and the Secret Store CSI Driver. And I'm super excited to be giving this talk with my friend and colleague, Daniel Hicks. So we will, let's see if I can get the slide to advance. We'll talk a little bit about us, and then we'll talk about what we're going to cover today. So Daniel, tell us about yourself.
Sure thing. So I'm a software engineer on the storage platforms team. We're working on a Kubernetes platform. So I'm excited to give the talk about the external secrets operator, since I am also a contributor to the project. So I quite enjoy it myself.
Excellent. And where do you live, and what's your background?
Sure. I live near Austin, Texas, and I have worked at several companies before DigitalOcean, but I've only been a software engineer for 4-ish years now, and I graduated from West Texas A&M, so go Buffs.
All right, nice. Thanks, Daniel. So I'm Kim. I'm a developer advocate at DigitalOcean. I focus on cloud native technologies, but mostly Kubernetes. And I live in Denver, Colorado in the US. And I got to know Daniel a little bit because he needed some help with our cross-plane provider, which I've done some work on. I'd like to do more on. And we're excited. So we're going to be talking about 2 different ways of managing Kubernetes secrets. And we already have some people who are telling us where they're from. So thank you so much. So yeah, if you are watching and you are able to leave a comment, tell us who you are and where you're from, and we'll look at a few folks. We've got Ingen, who's one of our regular viewers. Welcome, Ingen. It's nice to see you. Swilan, also regular viewer from St. Lucia. Great to have you. We've got Marcos from Argentina. Wonderful to have you. Say hey in the chat. And also, we want to let you know you can ask questions in the chat. We're going to have to figure out a good time to stop and talk about them. But if you see something you want to know more about, ask us in the chat. Let's get started. This is our agenda for the talk. We're going to talk about a few things. So the first thing is we're going to talk about what is an external secrets provider and what are the benefits of using that. Then Daniel's going to take over, and he's going to do a demo of the external secrets operator project. He'll talk through that. And then once he's done, I'll do a demo of a slightly different project called the Secret Store CSI Driver. Then we'll have a conversation with each other and hopefully with you, comparing and contrasting the 2 projects. One reason we wanted to do this talk is that people ask the question often in like the Kubernetes Slack, which one's better, the external secrets operator or the Secret Store CSI Driver? And then we'll do a recap. And if you are a regular Cloud Chats viewer, that's our weekly Tech Talk. Let's see. What am I looking for? It's our talk show where we talk about tech. We're going to do a Kahoot at the end so you can win some DigitalOcean swag. And we've got some more folks saying hey. So we've got Hela from France. Welcome. Stefano from Italy. JF from sunny California in the US. Moise from Pakistan. So nice to have you. I'm not sure how to say your name because I don't read that character set, but hello from Taiwan. It's wonderful to have you. And Mengs, great to see you. All right, so let's get to it. The first thing we're going to talk about are the benefits of an external secrets provider or an external secret management system. And so before we dig into the benefits, Daniel, can you describe why is it external? How is it a secrets management system? What are these things?
Sure. So an external secret management system are usually generally some sort of battle-tested software or offering from somebody that can sort of provide secrets as a service. So they'll take care of the encryption and decryption usually for you. It's usually compliant with most up-to-date security standards. And some of them are self-hosted and some of them are, say, up in the cloud. Good examples are HashiCorp Vault, which is something that you can run yourself, or they have their own cloud offering, or there's like AWS Secrets Manager, or Google Cloud Secret Manager, or Azure, et cetera, et cetera. But they're usually the most secure way to store secrets.
And so I like that. So they're external, meaning like they're not running in the Kubernetes cluster?
Yeah.
Okay, so it's something separate, like maybe it's running on a droplet or an EC2 instance or something like that. And like you said, it encrypts and decrypts, and it's like a managed service in a lot of ways where some of that work, the software itself does that. So very cool. All right, well, let's talk through some of the benefits. So I'll go with, oh no, I'm going too fast. So the first benefit of using something like, what do we say? There's AWS Secrets Manager, Azure Key Vault. We have HashiCorp Vault, which is what we're using today, and a keyless, is that you get a secure encrypted location for your secrets that's outside of your Kubernetes cluster. So it's something you don't have to run inside your cluster, which has some benefits. The next one.
Sure. And one of the main benefits. Yeah, one of the main benefits is that there is generally, if you use the API or libraries to interact with this service, you've already been authenticated. So they'll usually take care of the encryption and decryption for you. So when you put in a secret, you usually don't have to encrypt it and then put it in. It's usually just, hey, please put this in there and it'll encrypt it. And the same for when you get it out, they'll decrypt it for you and just send you the text that you actually care about.
Nice. So you don't have to like do the base 64 encoding and then have some way of doing that. Yeah, so I think that's the next. Oh yeah, this is like, these are just some other projects. So the other way of managing secrets is you, the end user, encrypt and you set up a key inside your cluster that decrypts the secret in the cluster. And there are some projects, one's called Sealed Secrets. Another one is from Mozilla called SOPs. And those definitely have a time and place. No, we're not saying those aren't good. We're just not looking at that today. We're looking at something with an external management system. So the next benefit is that when you use an external secrets management system, you can scope the secrets to specific RBAC roles. So you can say this secret should only be available in this namespace or by this particular role. And it's just a nice way to lock down where the secrets are available. Let's see, next one.
Sure. And then you can also do fun things like the versioning of secrets. So say I change a secret and it changes how my application works. If your application is not up to date to work with a new secret, you can version them per se. Or you can track how a secret has changed over time and track it via version. So what changed from version 1 to version 2 and things of that nature, which gives various use cases and benefits of just what you might use it for.
Yeah, I like in Vault where you create a secret and then there's also metadata that gets created saying like, this is the timestamp, this is the version of the secret. Like, I think that's really helpful. You don't have to like go through your git commit to see where the change was made. All right, the next benefit, yes, is that a security team can manage the secret system, not Kubernetes. And so if you're using like HashiCorp Vault, maybe you're at a big company, you want to have a separate security team where their expertise is actually the external secrets management system, but maybe they don't know anything about Kubernetes. Maybe that external secrets management system gets used on other non-Kubernetes projects. And it's nice because it's separate. It's not inside a cluster. So you can have folks who are not Kubernetes experts or even folks who aren't fluent in Kubernetes at all who can manage that secret system. And then your Kubernetes cluster can use it. So that's nice. That's really not something you can do with like the sealed secrets, SOPs. You're sort of doing all of that encrypting and decrypting in like a YAML manifest and requires a lot of Kubernetes knowledge. All right, next, yes.
Yeah, and the main benefit or a large benefit of these is a lot of them do provide some form of API to interact with them. So like Vault, there's a REST API that sits in front of it, as well as I believe a gRPC API inside of it that you can access. And this just eases sort of, automation or any other sort of interaction that's either via human or possibly not via human. If you wanted to write abstraction layers above them, you can do that because there's an API to interact with it. So that's sort of a very large benefit for teams that need to interact with these or possibly even host them, and they need a way to sort of gate access into them.
Yeah. And I like I was playing with Vault, getting ready for this talk. And, when you are using the REST API, you get errors that I sort of understand. So that's nice as well. Excellent. I think, is that the last one? That is the last one. But before we move on, we've got a couple of comments in the chat. So Engen asks, is encryption at rest like a benefit of using a secrets management system? I don't know. Daniel, do you know?
Yeah, normally everything is encrypted at rest for these systems, since that's sort of their sole purpose. Because that is a benefit over Kubernetes, because I know Kubernetes, I believe things are not encrypted at rest inside of etcd. So that is another benefit of using this system.
Excellent. And then Jerome says they're looking at 1Password secrets automation with DigitalOcean Kubernetes. Very cool. Yeah, I know 1Password has a command line tool where, you can store your secrets and get it to talk with a Kubernetes cluster. I did that at my last job. That was one of the tools we used for secrets management. So that sounds great, Jerome. Let us know how it goes.
I think they're actually looking to support it inside of the external secrets operator. So maybe you can use it with this.
All right. That's a benefit of the external secrets operator for sure. All right. Well, if you have questions, let us know in the chat. We've got a few more people who have said hello. So Fabiana from Amsterdam, hello. Hervé from France, and then Jerome from Atlanta, Georgia in the US. And Lucas giving us some tips.
There you go.
ESO now supports 1Password. The release just launched. That's awesome. Lucas, could you share a link for that in the chat, and we'll show it. All right, so what we just did was give a really high-level overview of the benefits of an external secrets provider. And we've already mentioned this, but the external secrets provider we're going to be demoing is HashiCorp Vault. And so I am going to pass it on to Daniel, who is going to do a demo of the external secrets operator. So,
all right. So for this demo, I'm running a cluster inside of DigitalOcean, just a DOKS cluster. And we're just going to be interacting with it and installing this external secrets operator and sort of just booting up a small external secrets. We also have a Vault instance running off to the side inside of a droplet. Just to sort of hook in that external. This could be running anywhere and using a multitude of providers that ESO offers. But to get started, I've already gone ahead and added the Helm repository. But we are just going to run a Helm install for this. Let's get this a little longer.
Nice. So you're creating a Helm release using the external secrets Helm project. Awesome.
And this should just run a real quick install, and we should have it up and running. We create a namespace for this from the external secrets namespace. That's with this create namespace flag. And we also set it to install the CRDs, because there are 4 CRDs that we install with the external secrets operator, and we'll go over those after this. But you can check that out. And that should be running if we get pods in the namespace external secrets. We can see them all running. So
awesome.
And then, so we have, as I mentioned, we have 4 CRDs with the external secrets operator. So we can take a look at those. Yes, yeah, ESO does stand for the external secrets operator.
Good question.
Yeah. I have a bunch of example files which we can go over.
Nice. And Daniel, what's a CRD in Kubernetes?
Sure. It's a custom resource definition. Each sort of operator, you can add custom resource definitions to Kubernetes to sort of define your own resources from the base one. So like a pod is a resource definition that's included in Kubernetes by default. But other people can build operators that extend that. So for example, with the external secrets operator, we add a secret store custom resource definition, which we can take a look at. in the example files.
Nice. And then this is a question on our quiz at the end, so pay attention.
So with this, this is the first sort of CRD that external secrets operator adds. You can see the kind right here, which defines its actual name of a secret store. This specifically just defines how external secrets talk to the provider. So you can see down here, we have a provider and we've defined it as Vault in this instance. This will be a multitude of other providers that they offer. Like I say, they have like one for AWS, GCP, Azure. I think there's even a Kubernetes operator where you can pull Kubernetes secrets from a Kubernetes cluster and spread it this way. But this, and each provider will have their own set of settings. So in this instance, this is saying I have a Vault instance. This is where you can reach it. This is my key value path. It's using versioning, so we're using the version 2. And this is how we would authenticate against it. This is just an example. So I have another one set aside that will apply that actually has our endpoint to Vault. But that's sort of a quick view on the secret store. And you can go to, I think it's external secrets or external-secrets.io. And we can post that in the chat.
Hear
that has all of these explained in depth.
Right. Cool. So you're creating a custom resource called a secret store, and that's how HashiCorp Vault gets involved in the Kubernetes cluster.
Yep. So we'll go ahead and apply this right here. As I mentioned, we've got a bunch of demo files as well.
Beautiful.
So we can just go ahead and apply that. All right, and then we will go and check it out. Let's make sure everything is happy.
Cool.
All right, and there you go. We can see our Vault backend that we've applied in there, and it has a status valid, so it's gone through and it's verified that it can connect to Vault and everything is good to go.
Nice.
So the next one, this is very similar to a secret store, and it's actually identical, is the cluster secret store, which, let me see if I can, which you can see looks exactly the same. The main difference, and in fact, this is actually not correct, but we'll change that real fast. The kind is a cluster secret store. The main difference is that a secret store is namespaced. So only external secrets from that namespace can reference a secret store in the single namespace. So if you have an external secret in a different namespace and you're trying to call on a secret store, that won't work. It'll say it can't find it. What you need for that instance is a cluster secret store. This might be something that's sort of a shared among teams path in Vault, for example, like say configuration for a bunch of apps or just whatever you need. That say a team that's managing external secrets operator can sort of manage and offer to other people using the Kubernetes cluster.
Nice, cool. All right, so we have a secret store, which is namespace, and the cluster secret store, which is available in all namespaces in the cluster.
Yep.
Cool.
And then we can go ahead. We will apply that as well, but we will not go check in on it. Wait for that to apply.
Sometimes it takes a while.
Yeah. Might skip this one. All right, we'll call this one good.
All right.
And then the last two are also very similar. And it's sort of along the same lines of it's along the same lines as the secret store, but they are called the external secret. So this is the sort of the bread and butter. So this is the thing that does all the work. This is
Ooh.
sort of the actually fetching the secret from Vault, or the definition of our secret inside of Vault, and then where we would like it to go.
Nice.
So this is, you can see we have like a refresh interval where if the value changes in Vault, this will actually sync and go and try to grab the new value every, in this example, 15 seconds.
Okay, cool.
So you can keep things up to date. Or for example, there's another project called, I believe it's called Updater. That's another Kubernetes project or operator that can actually detect changes to secrets that a pod uses and restart the pod or deployment.
Nice.
So like say if you have configuration changes, you can go ahead and update the pod that uses it.
Excellent. So does this create a Kubernetes secret, or does it create this, and it also creates this external secret resource?
Yeah, so this will make the external secret resource, and then you can see down here in the target is where you define the secret to be made. So this will be the name of my Kubernetes secret called my cool new secret. They have various creation policies. So owner here will actually create the secret and then sort of own that secret.
Okay, cool.
There are others like merge, where if the secret already exists, it can merge other values into the secret. And then I believe there's another one called absent, which just checks to see that it's there, and then we'll update it, but not merge it. I could be wrong on that one, but
okay. No, that's cool. There's different options for if a secret already exists.
And then data is like the data from Vault. So the secret key on the top is defining the actual secret key inside of the Kubernetes secret. But the remote ref is saying in Vault, I have a path ESO cool secret, and I have a property inside of it called my cool secret that I'd like to put into it.
Do you have Vault, the UI for Vault up and running? Could you show us?
I do not have it currently.
Okay,
but
I've got it, so I can show it. Do you want me to show yours, or
sure.
I can just show? Okay, cool. All right, let's see. We're gonna remove Daniel's. We're gonna add mine, and we're gonna show you what our Vault instance looks like. So, all right. So this is the UI for HashiCorp Vault. So Daniel set up an external instance of Vault for us on a DigitalOcean droplet. And let's see if we go to access. Let's go. Is yours in the key value?
Yeah.
Okay, there we go. So here's Daniel's path, the ESO for external secrets operator, and then the cool secret. And then here's his cool secret, and then the value. And is it okay if I share the value?
Yeah.
Okay. Oh, that is a cool secret. Bats are the only mammal that can actually fly. Okay, so this is the thing we want to see in the Kubernetes cluster once you've created all the custom resources and ESO has done its thing. Cool. All right, I will unshare my screen and add you back in there. There you go.
All right. And then might have a, there we go. Okay. I got Kubernetes to actually respond to me.
Woo.
Having a worry there that my cluster is not playing along. Let's do cluster secret store. All right, let's see if that goes through. All right, that one worked. All right, and then the last one, and this is just a super fast one because it's just like cluster secret store. We have a cluster external secret.
Got it. Okay.
So this one's slightly different. And this one I'm a little proud of just because I actually did the, all right, so I do not have an example of this, but we can go and look at the actual file. I actually finished this feature, so.
That's so cool.
I'm actually pretty proud of this one. This is a copy over from the website, and we will actually be doing this because I did change it. But the goal of using this is, so Kubernetes doesn't have a native way of copying secrets to various namespaces, or say, I want the secret in, say, X number of namespaces. Mm-hmm. So what this does is it will actually go and allow you to select namespaces via like labels and things of that nature. And it will actually create an external secret, each of the namespaces based on a template that you provide. So I have this one set up, and you can see right here under the namespace selector that it's going to match the labels where the component is my cool app.
Nice. Okay.
And then everything else is exactly the same as a external secret under the external secret spec. It's literally just the external secret from before.
Cool. That is very cool, and it's really neat you worked on it.
Yeah, it needed quite a bit of help from the team. So I'll give a big shout out to the external secrets team, as they were very helpful in
Excellent.
actually helping me do it. So let's get that in there. All right, and then I have just a quick, we're going to apply also some namespaces for that to actually interact with. So I have 3 namespaces, 2 should have the secret, 1 should not, which are not as cool namespace. And then we'll also, just for funsies, apply the actual external secret, which is just going to be running in a default namespace. So we can pop in here and we can do keepctl get external secret. And here we can see varying things. So we see that would be the secret store. So we have my cool secret right here, which is the external secret. And we can see that says secret synced. So we can actually go and check out kubectl get secret, as it should be in this namespace. And you can see the my cool secret right there, along with the vault token, which is what we use to connect to vault. But I have a quick copy and pasted command because for some reason this is not a super easy thing to do. But we're going to go get that secret, and we're going to see bats are a mammal that can.
Yay! Look at that secret.
So, woo!
From vault to your cluster.
Yep. And then we will run a quick kubectl get. We're going to look for some external secrets. But we're going to change our namespace, and we're going to go look at, let me double check my namespaces.
Sure.
Our cool namespace. And there we can see our external secret right here, the my cool secret, and that it was synced. And so we could also pop in here and just pull secrets, and we should see it as well. And you can see it, it's the my cool secret. And then the last one is just to show you that I'm not fibbing. We can go look at the not as cool namespace, which isn't as cool as our normal namespaces, so it shouldn't have one.
Okay.
Lo and behold, all we have is our belt backend cluster, which is a cluster scoped, and our cluster secret, which is also cluster scoped, so they'll appear here as well. But we don't see the other secret because it's not as cool. It's not as cool as a namespace. So
awesome. Well, that's great. Thank you for sharing. Let's take a look at the comments. So I think Luca is giving us another benefit of using an external secret store, saying like it's also helpful for multi-tenancy solutions. So if you have multiple Kubernetes clusters, you could set up Vault to interact with all of them. So yeah, that makes sense. Ingen, I think responding to when you were talking about like refresh interval, that Reloader is also a similar project that does that.
I think the reloader was what I was thinking of when it reloads deployments. Like when the secret changes, it will go and reload or redeploy the deployment and or restart pods.
Yeah. We've got Paul saying hi from Tampa. Hello, Paul. And then Dan, I think, giving us some information about custom resource definitions. Kubernetes has an API. You can extend the API and provide controller containers to respond to those requests. Outstanding. And then Luca just gave us a heart. And I have a cat in my lap getting up. So if you see a tail or something, that's what's going on. Oh, he just jumped off. Hi, Kamran. Nice to see you. Cool. Well, I think it's my turn to share my screen, and let me do that. So Daniel just did an awesome demo of the external secrets operator, and what's going to happen next is I'm going to do a demo of the secret store CSI driver, which is a project that does similar kinds of work in a Kubernetes cluster, but is different. And then we're going to need everybody's help telling us the differences and the similarities between the two projects. So yeah, keep an eye on that. And then hello, Vafa from Berlin. Nice to have you. All right. So I'm going to start and I'm going to show you in Vault. So this is the key value store, and I have a secret. It's at this path called secret, and it's a token. And the key name is token, and the value is this string. It starts with A and N. So our goal is we want to get this secret into my Kubernetes cluster so that an application can use that token because it's important for the application. So, all right, I'm going to share this in the chat. I'm going to be using this tutorial, and then I have a separate DigitalOcean Kubernetes cluster from Daniel, but let's just make sure I'm connected to it. So I'll just say kubectl get nodes. All right, perfect. So I've got 3 nodes, and then kubectl get namespaces. All right, I have my default namespaces like kube node lease, kube public. I have a namespace called secret store, and then I'm going to create a new namespace for this demo. So let's look at the tutorial. My cluster's prepared. I've already set up HashiCorp Vault. You already saw the credential is stored in the Vault KV storage, but this command is what I use to put it there. Set up Kubernetes auth in Vault. And so we're on step 5. It's nice to skip so fast to that step.
Making progress.
Exactly. So the first thing I'm going to do is I'm going to install the secret store CSI driver using Helm. So Daniel did the same thing. I think I already have this Helm repo installed. Yep, looks good. But I will update it in case there's any updates since the last time I installed that repo. Looks good. And so now what I'm going to do is I'm going to install the secret store CSI driver in a namespace called demo. And let me create that namespace. So kubectl create namespace named demo. Looks good. And one of the flags I have here is I'm enabling this thing called secret sync. So if you want secret store CSI driver to be able to create Kubernetes secrets, you have to enable that. So let me grab this command and we'll install that. And it might take a minute. All right, while we're waiting for that, let's see what's next. So the next thing we're going to do, so I said create new Kubernetes objects so your app can use the CSI driver to create an ephemeral volume. Okay. Well, that's basically what Daniel showed us. Great. Okay, so it looks like the Helm release was created. I'm going to verify that by just seeing what are the pods in the demo namespace. All right, so I have these 3 secret store CSI driver pods running. Secret store CSI driver gets installed as a daemon set, so you get 1 pod per node. So like if we were auto scaling up and we had 5 nodes, then we would have 5 pods. If we were just running 2 nodes, we'd have 2. But yeah, let's do the next thing. So this is what Daniel was showing. He was showing all of these custom resources that he was creating. So in the CSI driver, there's a custom resource called the secret provider class. So let's take a look at that. So this is the YAML manifest for that. And here's the name. And then I'm calling this secret provider class Vault Demo. I'm going to install it in the demo namespace. And then just like we had with Daniel, what was the name of the ESO CRD?
Secret store?
Secret store. Okay, so just like the secret store, the secret provider class, you have to say, here's the external secrets management system I'm using. I'm using HashiCorp Vault. Here's the address, the role name, and then here's where you're going to get the data I have stored. So we saw that secret token, so all of that. So let's create that. So that's in my manifest directory. So I'm going to say kubectl, apply the file, the manifest directory called secret provider class. All right, looks like that was created. Let's just look at that. So we'll say kubectl get secret provider class from the namespace demo. All right, so this is saying like, hey, I'm connected to the Vault, the HashiCorp Vault. It's called Vault Database. Doesn't have that nice. I think the ESO had the nice like message like it's synced, it's working. Doesn't have that. I bet if we described it, we'd see.
Yeah, they generally have them under the status section. Just
nice.
not there's some special field that they have to fill out to actually show up in the kubectl command.
I see. Right, and issued a file on the secret store CSI driver repo. Yeah, so this is just information about that. And there's no event, so that's probably good news. All right, so then the next thing that I'm going to create is I need to create a service account. So I created a policy in HashiCorp Vault saying, hey, you can allow applications that have this service account to do the following thing. And okay. We can go look at that. Let's see if I can find it.
And so okay,
here it is.
The service accounts are the Kubernetes service accounts for various RBAC?
Yep,
okay.
Absolutely. And in Vault, I've created a policy called app permission. And I'm saying, any service account that's linked with that permission can access this path in Vault, and it can only read the secret. It can't write to it.
Okay.
So just kind of like locking down those permissions. So my service account YAML is pretty plain. I could probably just do this with a command, but I like having a manifest there. So let's create that. So kubectl apply the file in the manifest directory called service account. Awesome. And then the last thing I'm going to do is I'm going to create a pod, and it's just a BusyBox pod. But I want the pod to have access to the secrets that I'm pulling in from Vault. And so what Secret Store CSI driver does is it creates an ephemeral volume. So whenever a pod gets spun up, volume gets spun up as well, and that's where the secret gets stored. And so there's information about the volume mounts and the volumes here. And we're specifying the secret provider class. That's the thing that we just looked at. So to make sure that they're all connected. So I'm going to create that pod with kubectl apply manifest. I call this a deployment. It's not a deployment. It's a pod. I'm going to change it to a deployment in the future. I know you shouldn't run bare pods in Kubernetes. But yeah, let's make sure that pod actually got spun up, because in prepping for this, sometimes the BusyBox pod wasn't working because I didn't have things configured properly. All right, so BusyBox looks good. And so the next thing that I want to do is I want to give my app access to that actual secret. And I have some things that I need to uncomment out and then reapply these files. So this is the secret provider class, and I'm going to uncomment this. And what I'm saying is, hey, I want you to create a Kubernetes secret when you get that data from Vault. And we're going to call the secret KV secret 1. It's the opaque type, just sort of like the secret type we use for applications. And then the object name is going to be token, and I need you to get the token and store the value. So let's reapply that. So kubectl apply the file manifests.
So,
and that is, go ahead.
So as before, it was just, if you went into the BusyBox pod, there would be a file path under your volume with your secret currently. And this is just making an actual secret in Kubernetes now instead.
Absolutely. Yeah.
Okay.
Good question. All right, so that looks good. And then there's one other section we need to uncomment. So this is the BusyBox YAML manifest. And I want my BusyBox pod to just be able to access that secret data in an environment variable instead of like on the file path. So I'm creating an environment variable. It's going to be named API token, and it's going to grab the value from KV secret 1 and then the token. So let's apply that. So my deployment. Oh, I got to delete because it's not a deployment. This is why you don't run bare pods, people. Keep control, delete pod, BusyBox, namespace demo. Also, I see there is an awesome conversation going on in chat about ESO versus sealed secrets and some other stuff. We'll absolutely address that once the demos are over. So great discussion. All right. And then it takes a while, I think, because it's deleting the volume that it's created. Go, go, go.
I was having some timeout issues as well. So
that's all right. It happens. Oh, yeah. So in the tutorial, now I'm on step 7, which is syncing the Kubernetes or creating a Kubernetes secret and then setting the environment variable in the pod. All right. That looks good. So then I want to exec into that BusyBox pod and just prove to you that that value is now stored as an environment variable. So let's just double check. So this is our external secrets manager vault. I have this token with this value A9N. We want to see that in the pod. Let's see. So cube control exec.
You might need to reapply it since.
Oh yeah, you're absolutely right.
Yeah.
Because there's no pod currently.
Yeah.
Cube control, apply the file manifest, deployment, that's actually a pod. All right, and then I'm just going to grab the command. Okay, I'm going to exec into that BusyBox pod. Okay, we see my command line prompt change, so I'm in that pod. And if I say env, aha, look at that. So yeah, the token gets stored as a secret, and then from there, you just do your regular workflow with how do you pull secrets into a pod. But one thing I do want to show, Daniel showed this as well. So cube control get, I got to remember what the resources are called. Service account, secret provider class. I guess it's just the secret. Cube control get secrets from the demo namespace. I probably should have showed you this before, but this is just proof that by updating the secret provider class with the secret sync option and then booting up that pod, that the secret got created. And so I think just like Daniel showed, you can get your regular old Kubernetes secrets from the CSI driver. So, all right.
Very cool.
All right, that was a lot. Daniel, do you have questions about that?
I don't have any questions. It seemed pretty interesting because I've been meaning to take a look at it. So thank you.
Yeah. All right, let's quickly just look at the conversation folks are having.
Yes.
So I'm going to pull up some of these.
I believe further up, there was the question of, yeah.
All right, so DDD says, what is your opinion on sealed secrets versus ESO? So we'll read through the chat and then Daniel and I can talk through our opinions. So Gustavo says, sealed secrets is a way to have secrets encrypted into a source and also available in the cluster decrypted. That is true. So sealed secrets is one of those projects where you as the end user like encrypt your secret in probably a YAML manifest. But it's nice because then you can push that secret up to a public Git repo and the decryption happens in the cluster. So it's a nice way to manage secrets. Gustavo follows up with ESO. So external secrets operator is a way to have secret metadata into a source via external secrets and also available in the cluster decrypted. Okay, so the sealed secrets doesn't have that external secret store.
Yeah.
Gustavo says they are very similar. I think the use of one versus another depends on the level you want your developers to know the secret content. I think that's Excellent. And then Dan chimes in and says, if key rotation is not in your vocabulary, then sealed secrets will keep you going until eventually it is.
So this is a benefit that I actually forgot to cover in the benefits from the external secrets providers.
Nice.
So Vault and various other things, they can actually rotate keys themselves. So if you have a token that you're generating for, say, where it's like a secret key or something of that nature for like a token, for example, or an API key, Vault can actually handle rotating that for you and generating a new one.
Oh, very cool. Okay, so Vault does that. Nice.
Yeah, and I'm sure the other, I'm only familiar with Vault myself, but I'm sure the other providers also have this feature.
Excellent. And then DDD, last comment, indeed, except sealed secrets are a bit more distributed and harder to manage. We are currently using Spring Boot Vault solution since it can eliminate many issues, but we run, it sounds like, Spring Boot Vault in both like on separate VMs as well as inside Kubernetes. Yeah. So yeah, like that's a great conversation. That's sort of the conversation Daniel and I wanted to have was like, what are the benefits? So there's sort of like two categories of secrets management. One is using the external secrets system like we're doing. And then there's like encrypting and decrypting on your own. Beautiful. All right. Daniel, anything to add about ESO, secret store, CSI driver, sealed secrets?
Not off the top of my head. I know I will say for ESO, there is a bunch of other stuff that I didn't cover. So they have like some pretty hardcore templating features. So like, for example, if I have like my connection details for a database, you can actually build the connection string in the template for the external secret instead of saying, just pull all these different ones and then my app will put it together. You can actually put stuff together yourself inside of the secret.
Very cool.
Along with, there's a bunch of different ways, like I had mentioned, the Kubernetes provider. You can use that conjoined with the cluster external secrets, for example, to hook together a way to sort of shoot or shotgun a Kubernetes secret across an entire cluster. Since I know we had been looking into that and wanting to do that. But for example, one of the downsides of ESO is that each external secret will hit the provider. So if your provider can't handle tons of traffic like that, or it's getting a little bit, you can have one that pulls down the secret and then shotgun it across other namespaces.
Okay, very cool. Very cool. All right, I put something in the chat that I wanted to share. So we have this tutorial from DigitalOcean. It's called the Kubernetes Starter Kit. And this chapter 8, is actually how to use sealed secrets to work with secrets. So if that's something you're interested in, this will show you how to do it. And I'm trying to see if there's like a manifest. Okay, so here's a good example of, this is the data that you encrypt on your machine, but it's safe to put that up in GitHub, which is really nice. So, or whatever system you use. Oh, here's another one. All right, so check that out if sealed secrets is something that you're interested in. All right.
And I will mention, just as a caveat, just for this, since we're talking about putting secrets from, say, Vault inside of Kubernetes, you might also, paired with this, look up actually encrypting data at rest in Kubernetes, since the secrets in Kubernetes, while they do say secrets, are not actually encrypted at rest. By default, they're just base 64 encoded. So just if you're shoving a bunch of secrets from Vault into Kubernetes, you might take a second look at actually encrypting those secrets as they sit. So
excellent. All right. So what we're going to do next is we're going to compare the two projects that we looked at. But before we do that, I want to invite you all to join us. We're going to do a Kahoot quiz. And so okay, so here's how you join. So you go to kahoot.it and then you enter this pin. And once Daniel and I are done with the compare contrast, we're going to do a recap, but it's going to be through this quiz. And if you win the quiz, we will send you some DigitalOcean stickers. So please join. We're going to have a banner describing, there we go. You can see that. Okay, and then the link for the Kahoot is, I'm going to type it, Kahoot. Oh, Gustavo's in there. .it. And then, oh, the pin is, I'm just going to put the pin. Okay, let me try this again. I've never done this in a tech talk before, so forgive me. Kahoot.it. And then the pin is, I don't know, 4300008. And we've already got folks joining, which is awesome. Keep joining. We're going to play that when we are done comparing and contrasting. All right. And we would also love your help on this part because we don't have anything written down. So let's start with similarities. How about that? So similarities between ESO and the secret store CSI driver. All right. Give me one, Daniel.
Okay. My first one would be that they can synchronize secrets from external secret sources, such as Vault and AWS Secret Manager and just others.
Excellent. Secret stores. Excellent. Okay, I got to make this way smaller. Yep, they both sync from external secret stores. Okay. Let's see. Do we have comments? Nope, not yet. Okay, so they sync from external secret stores. Yep. I don't know if this is too high level, but like you can install both of them with Helm.
They're both pretty easy to install in terms of that nature.
Yeah, both you can have. Yeah.
Gotta love the convenience factors.
It's super nice. Yeah. Okay. That's too big. Okay. Helm charts. We'll just say convenient Helm charts. Convenient Helm charts. What else? So some similarities.
They both use native Kubernetes secrets. They both create just regular secrets.
Both projects can create native Kubernetes secrets. Yep. And
there you go.
One. Thank you, Gustavo and Ingen. Oh yes, I'm sorry, Ingen. I missed your other two comments. Yes, Kubernetes native with custom resources, which we captured. GitOps ready, and then Gustavo. Yep, they are GitOps friendly because you can automate the creation, and you have those YAML manifests, which is really nice because you can put it in a repo and update it and audit and trigger automatic changes. It's wonderful. So GitOps friendly. All right. Let's do the differences. I'll copy this.
And if you can think of any other similarities, feel free to just shout them out while we're still going over.
Absolutely. Yeah. I'm sure we've missed some. It's hard to do this live. Okay. So some differences.
So I will say the number one difference I noticed between the two, I believe CSI pushes they only allow interaction via gRPC to the providers, and they require the providers to make their own interactions.
Okay, so CSI, so you can't use like HTTP requests with the CSI provider?
At least to, like, for example, for Vault, HashiCorp has their own provider made.
That's right.
And it uses gRPC.
Okay.
With external secrets, the providers are inside of the actual repository and are generally maintained by the actual maintainers of ESO.
Got it. Okay. So it's maybe less flexible is kind of what the end of that is.
Yeah, it's more of it's on the community to build the
okay, so that makes sense. Okay, so the community must build providers. Yep, you didn't see me do it, but I installed the HashiCorp Vault provider to get my demo working.
Which I will say, the providers for ESO are community maintained as well. Like say they're located in external secrets, not the external secrets provider, not like a separate repository.
Excellent. Okay, that makes sense. Yeah, like Vault is the organization that maintains the Vault provider, not the Kubernetes CSI driver. I'm going to say that I think the CSI Vault project is setting up Kubernetes auth is harder than ESO. Does that sound right? Okay.
Yeah.
So this CSI driver Kubernetes.
Or they, and it might be different for other providers, but yeah, the Vault one specifically only does Kubernetes auth, and ESO does. I think there's like tokens, Kubernetes auth, and app roles, and then things of that nature.
Last tokens, Kubernetes auth. What was the third one?
App roles.
Can you spell that?
App roles is just app roles.
Oh, app roles. Got it.
Yeah.
I know what you mean.
And then I think it's roles is like
not
my role. Yeah.
Yes. Sorry. Homophones.
You're fine. Same word, different spelling. Yeah.
Yeah. Other differences. So I know that in ESO, there's that feature where you can, I think you were saying like slingshot secrets into different namespaces. I don't believe that is a feature in the CSI driver.
Yeah. So, multi-namespace, I guess.
Yeah. Enables, multi-namespace secrets. Excellent. And then Lucas has a comment. They say CSI driver's biggest advantage is if you need to avoid having secrets in your cluster. Oh, and having them only mounted in pods. That's awesome.
That is pretty good. That's
I would not have been able to articulate that. So CSI, you can mount secrets only in your pod.
Or you can
go ahead.
Avoid creating a Kubernetes secret.
That's right. I showed you how to do that, but you don't have to do that.
Yeah.
And in fact, like you have to enable some flags to do that. So can you say that again, Daniel?
You can avoid creating native Kubernetes secrets.
Excellent.
And just mount like what you had before. You can just mount them into pods.
Thanks, Lucas. Lucas, are you part of the CSI driver team?
Lucas and Gustavo are they're the maintainers for the external secrets operator.
Oh, how special. That's awesome. Thanks for being here, y'all. Oh, we got another one from Lucas. ESO, on the other hand, lets you leverage secrets that will never be in a pod. Oh, this is so good. Okay. ESO allows you to create secrets that are never in a pod, Docker, config, JSON, ingress, certs, etc. That's so good. Thank you, guys.
I will say the CSI driver does let you specify a type of secret, though, correct?
Yes, I believe so. I guess you could do that.
Yeah, so I think you could. Depends on if they support that type. I'd have to look at their docs to see what types of secrets they support.
Cool. All right. Well, we will leave the comparing and contrasting there. I'm sure there's more. This has been really helpful, though. And so the last thing we're going to do is our recap. And so we are going to do the Kahoot quiz. I'm so excited. We've got all these folks signed up to play. And so we're going to get started. This is a short quiz. I think it's only 4 questions, but here we go. All right. So this is external secrets operator versus secret store CSI driver. All right, first question. Which is not a reason to use an external secrets management system? Which is not a reason to use something like HashiCorp Vault. So is it A, scope secrets to specific RBAC roles? B, encrypted secrets can be stored in a public Git repository. C, automatic versioning of secrets. And D, no encryption or decryption required for the end user. I gotta go faster on the reading. So the correct answer is the blue diamond. So external secrets management systems. You don't you don't handle the secret really except for putting it in Vault. And so it's not true. You cannot store encrypted secrets in a Git repository if you're using an external. I guess that's maybe not true, but from what we showed you, that's not true. All right. Let me see if I can play with the amount of time. It doesn't look like it. All right. Next up.
Speed
the leaderboard. All right. In first place is A1B2 C3D7E5. In second place is Giorgio. And in third place is Fabio. And part of how Kahoot works is you have to get the right answer to get a point, but the faster you answer, the more points you get. So let's see the next question. Which custom resource is not part of the external secret store? So this is ESO. Which one is not part of the external secret store? Is it the secret controller, an external secret, the secret store, or the cluster secret store? So which one of those is not part of ESO? ESO? Yeah. Wow, look at y'all. You did great. So the answer is secret controller. I think I just made that up. Or is that what the thing is called in no, okay. In the CSI driver, it's called the secret provider class. So excellent work. Yeah, and then Daniel was showing us there's sort of these mirror CRDs in the ESO where there's a cluster scoped one and then there's a namespace scoped one. All right, the leaderboard. A1B2 is still in first, Giorgio in second, and Salvatore is now in third. All right, next question. Secret Store CSI creates which custom resource? Is it the secrets provider class, a super secret, an external secret, or a secret store? Secret Store CSI driver creates which of those custom resources? I hope this was a gimme. So the answer is the secrets provider class, and that is the manifest I was just showing. So this is how you get the Secret Store CSI driver to connect with your external Vault instance, is the secrets provider class.
I kind of wish there was a CRD called Super Secret now. Super
Secret. Well, we can make it. The actual only time I've written a CRD from scratch was we have Deploy, which is like DigitalOcean's conference, and we needed like a joke essentially on like a video, and so I made like a Deploy CRD, and it like goes by on the video really fast. I'm like, oh, that was me. I made that. All right. In first place, we've got some change on the leaderboard. Giorgio's in first, A1B2 in second, and Salvatore in third. I think this is our last question. Yep. Last question. True or false? Secret Store CSI driver uses ephemeral volumes. True or false? Secret Store CSI driver makes use of ephemeral volumes.
And the ephemeral refers to just it goes away after it's not being used.
Yep, the volume life cycle is the same as the pod life cycle. So the pod spins up, the volume gets created. When a pod goes away, the volume goes away. That answer is true. CSI driver uses ephemeral volumes. All right, y'all. Thanks for playing our first Kahoot in a Tech Talk. Let's see who the leaderboard. So in third place, we have Salvatore. Excellent work. In second place, we've got A1B2. And in first place, we've got Giorgio. Nice work, Giorgio.
Nice.
So if you are Giorgio, please send me an email. I'm putting it in the chat right now with your name and your address. If you give me all the details of your address, because I'm going to ship you some stickers. So, the address, the city, the codes, maybe a phone number. But yeah, let me know that was you, and I will send you some DigitalOcean swag, the stickers. All right, and we will exit out of this. Nice. There's Giorgio.
Nice.
All right. Well, any other final things to recap, Daniel, that we didn't cover in the compare contrast and the and the Kahoot.
I think we covered it all pretty good, especially in the compare and contrast.
Excellent.
Thank you, everybody.
Yeah, well, you've got a link to the slide deck. We've got these resources. Both Daniel and I are writing DigitalOcean tutorials on the thing that we presented on. So it'll probably be a few weeks or months before those get published, but look for that. Thank you so much for joining us. This was really fun. Thanks, Daniel, for doing a tech talk with me.
No problem. I enjoyed it.
Daniel's handle on most things is a dusty old muffin, which is one of my favorite handles. And my handle on like Twitter, GitHub is @KimSchless. So say hi at one of those things, and we will see you all next time. Thanks so much.
Thank you, everybody.
Bye.